Hello everyone, this is Nitika Kathuria. Today I'm going to present on the topic optical computing. Let me quickly brush you through the topics which we are going to discuss in this presentation. We are going to discuss about optical computing, optical components for binary digital computer, silicon phonetics, developments in optical computing, about light chips, optical computers, the architecture, advantages, challenges, and in the end we'll have conclusion and references. Now, what is optical computing? In a technical language, optical computing uses photons produced by lasers or diodes for computation. For decades, photons have promised to allow a higher bandwidth than the electrons used in conventional computers. Basically, it is the use of a device that uses photons rather than electrons to perform digital computations. But in a simple language, in a layman's language, it is the integration of electrical and optical devices on the same piece of silicon, enabling computer chips to communicate using pulses of light instead of electrical signals, resulting in smaller, faster, and more power efficient chips than was possible with conventional technologies. Optical computing is also known as optoelectron computing. Next, we have optical components for binary digital computer. The fundamental building block of modern electronic computers is the transistor. Now, what is a transistor? A transistor is a device which is used to amplify or switch electronic signals and electrical power. This transistor has to be replaced with an optical transistor. An optical transistor is a device that switches or amplifies optical signals. This is achieved using materials with a non-linear diffractive index. So these will be non-linear crystals used to manipulate light beams into controlling others. There's a term that is known as optical transistor effect, which is used to create logic gates, which in turn are assembled into higher level components of the computer's CPU. Next, we have silicon phonetics. This is a research topic which is useful in optical computing. So it is the study and application of photonic systems which uses silicon as an optical medium. It's a new approach to make optical devices out of silicon and uses light to move huge amounts of data at high speeds and uses low power over a thin optical fiber rather than using electrical signals over a copper cable. This study will help the industry to keep pace with the increasing demands in the chip performance and computing power. Hence, knowledge about silicon photonics becomes important and is required in order to survive in the industry. Moving on to developments in optical computing. The era of optical computing started in 1980s and there has been a considerable progress in this domain in order to fulfill the development of optical computers. The starting point was the development of optical logic gate. What is a logic gate? A logic gate is a device that performs a certain Boolean logic operation on one or more logical inputs and produces a single logical output. An optical logic gate is a switch that controls one light beam by another. If it is on, it can transmit the light. If it is off, it will block the light. Then we have optical transistor. All optical transistor switch that's controlled by a single photon, allowing light to govern the transmission of light. So the experimental realization of the fundamental component of computing circuit has been developed. This switch can also be used as a photon detector. If the photon has struck the atoms, light won't pass through the cavity. That means we have a device that can detect a photon without destroying it. Next is optoelectronic chip that computes electronically but uses light to move information. Now, new development means optical technologies are starting to appear inside computers. The all optical computer is still to be developed, but selected components that can work with light will make their way into computers much more easier. Moving on to light chips. Light is a source of inspiration in computing. Since the first optical transistor were developed in late 1980s, researchers have aimed of building a light-powered computer radiating with knowledge. So light chip is a new memory chip that can store data not with electricity but with light. So it's the first on-chip non-volatile optical memory. It does not require a constant supply of energy. The basis of this technology is so-called phase change material. The distinguished feature of phase change material is that they radically change their optical properties depending on their phase state or the arrangement of atoms within them. Light pulses can be used to switch the material between two distinct states, one in which the atoms are ordered or crystalline and the one in which they are disordered or amorphous. Certain merits of light chips are they provide long term storage like hard drive. They transfer data at high speeds and consumes minute amounts of energy. Multiple parallel data streams encoded on different colors of light can be sent over the same medium. They have large bandwidth, they have small wavelength, they uses light instead of electricity to move information, and its processor leads to much faster and more energy efficient computers. Next we have optical computers. Optical computers are also known as photonic computers. Presently, optical computers, when we talk about optical computing, we are actually referring to a fairly large amount of different and competing technologies. At its most basic, it refers to computing that uses light instead of electricity. Presently, computers process information via electrons, but the next step is to design an optical computer that processes information with the help of light. An optical computer is a device that uses photons rather than electric current to perform digital computations. There are two types of optical computers: electro-optical computers and pure optical computers. Electro-optical computers uses optical fibers as well as electric parts to read and direct data from the processor. Whereas pure optical computers, information is sent throughout the computer with the help of light waves and packets. Next we have architecture of optical computing. For an optical computing, we require an optical source. We also need an information which has to be processed. We need a method of modulating the sources to carry the input information, and in the end we have a stage to process information or make a decision. In short, processing optical information involves generation, propagation and detection of light. Now, why optics for computing? Optical interconnections and optical integrated circuits have several advantages over their electronic counterparts. The foremost advantage is that they are immune to electromagnetic interference, that they are free from electrical short circuits. They have large bandwidth, they have low loss transmission, they allow the transfer of data without any distortion or crosstalk. They move faster than electrons. Light moves faster than electrons because speed of light is more than speed of electrons, and speedy delivery of data is ensured when using optics. They are compact, lightweight and also inexpensive. Certain challenges and prospects in optical computing. Optical computing is a nonlinear process in which multiple signals must interact. We all know that light is an electromagnetic wave and can interact with another electromagnetic wave, and the strength of this interaction is weaker as compared to electronic signals. So this is a major challenge. Second challenge is the cascadability. Cascadability to integrate a large number of all optical gates is a highly complex problem, and it's a major obstacle in the way of building a complete optical computing system. Then we also have to deal with noise that interferes with the signal, then also material development and funding issue. Coordination and cooperation amongst various departments like material sciences, chemists, physicists, computer architects, optical engineers has to be done in order to make the process faster and easier. Apart from all these challenges, the major challenge is to find a single material that can effectively use and control light to carry information around a computer. Much like how the web uses light to deliver information, we want to use light to both deliver and process computer data. But researchers have found and have developed Chalcogenides. Chalcogenides have some useful properties. They're able to conduct light across a pretty wide range of bandwidths. This means that they were able to create the useful optical material without needing high temperatures and also without using large amount of doping agents, something that has in the past rendered chalcogenides incompatible with the current computing technologies. So, researchers have unlocked the potential by doping glass with an ion of the element bismuth. This has enabled the material to act as a light source, a light guide, and a light detector, something that can interpret optical information. In doing so, this could transform the computers of tomorrow, allowing them to effectively process information at much faster speeds. Now, advantages of optical computing. Optical computing is exciting for two main reasons. First, they are power efficient. They consumes very little power. Second, they have high level of parallelism. In a normal computer chip, while there is some parallelism, most things happen very sequentially, almost in serial. But in optical computers, they're capable of performing hundreds or thousands of small computations in parallel. There's no limit on how parallel it can be. Also, they're capable of delivering a high performance. They perform computations faster. In the next slide of today's presentation, we are going to discuss about the scope or future of optical computing technology. Computers have enhanced human life to a great extent. The speed of conventional computers is achieved by reducing the size of electronic components so that electrons travel short distances within a very short time. Optical components like gates, transistors, memory will lead to the realization of optical computers in the near future. Optical technology promises massive upgrades in efficiency and speed of computers in addition to shrinkage in size and cost. Basically, the computer industry has been interested in optical computing because of the possibility that the conventional electronics soon will reach the limits of miniaturization. It has been observed that there is a large push to enable optical computing using the same techniques similar to silicon. This new technology could pave the way for faster, more powerful computing systems and network infrastructure. One of the leaders in this push is Intel, that is the creator of an integrated silicon photonics link which can transmit 50 gigabits per second of uncorrupted information. Intel is contributing in the development of this new technology. They've produced devices which act like a stepping stone to full optical computing. In spite of all these challenges, scientists still speculate the development of speed of light optical computer by 2020. Well, the history of development of the research in the field of optical computing reveals an extraordinary scientific adventure. And we all hope that in distant future, the dream of fully operational optical computers will soon be realized. In the last slide, I have listed all the references that were used in order to prepare for this topic. I hope you enjoyed this presentation. Thank you and have a great day.